AB Calculus, Notecard 28, Natural Exponential Function. This is the 28th lesson in the series inspired by Stacy McMullen, formerly of the Dallas Independent School District. Natural Exponential Function. And as just a few facts about that, the inverse of f of x equals e to the x is f negative 1 of x, or the inverse function of x is ln x. And so I'm just going to draw what that would look like here. So ln x is going to look something like this. Okay, and I'm drawing here in black. That'll be ln x. Okay, it'd be f negative 1 of x equals ln x. Let me get a skinnier pen here. Okay. Continuous, increasing everywhere, monotonic, and above the x-axis. Also, since the function is increasing everywhere, f prime of x is going to be greater than 0 everywhere. Okay, the limit as x approaches negative infinity of e to the x equals 0, and that would be as we go to the left, and limit as x approaches infinity of e to the x as x is going to the right is infinity. So exponential functions grow faster than polynomial or logarithmic functions. And a very unique feature of the natural exponential function is the derivative of e to the x is e to the x. And the only reason it's not going to be e to the x if we have a different value of x, like if we had e to the 2x, then it would be different using the chain rule. Anyway, we're going to go over some problems using this. Find the derivatives. Y equals e to the power of 2x minus 1. So y prime, our derivative, is going to be e to the 2x minus 1 times the derivative of this argument here, which is going to be 2. So y prime is going to be equal to 2e to the power of 2x minus 1. So that's problem number 1. Problem number 2, if f of x equals e to the power of 2x over 2x, then find f prime of x. And I hope you are able to recognize that this is the quotient of two functions. So we can call this one up here high, and the one down here low. So a high function is equal to e to the 2x, and the low, we put d high. D high is going to be equal to 2e to the 2x power. The low is going to be 2x, and the d low is equal to 2. So f prime of x is equal to low d high, low d high, low d high, that's 2, power of 2x, minus high, e to 2x, high, d low, all over low squared. So we have 4. X squared will be low squared here, right? So just simplifying up a little bit, we have a factor of 2 in each case, but in this case we're going to have, well, we're also going to have e to the 2x, aren't we? Yeah, so we can factor more stuff out of here. So we have 2 e to the power of 2x And what do we have left here? I think we just have 2x, right? And then minus 1. Is that right? Because that's where we're going to get it. And I think it's going to be over 4x squared. I believe that's going to get it. And we can find where the function is increasing or decreasing by setting this numerator equal to 0 and so forth. Okay, 3. If f of x equals e to the x power, which the following is equal to f prime of e? Well, I'm going to write the basic definition of derivative. Limit as h approaches 0 of f of x plus h minus f of x over h is going to be equal to f prime of x. So we're going to take this basic format, and so what we basically have is, according to this, we're going to have our f of x is going to be e to the x power. And then if we have f to the e, f of e is going to be equal e to the power of e. And so basically, we're going to have up here, limit as h approaches 0, we're going to have f of x, which is going to be e to the e, x plus h minus e to the e over h. So where do we see such a thing? I'm thinking Roman numeral 3 is, or letter C is looking pretty good. So that looks like letter C to me. It looks like the other ones aren't it exactly. Yeah. So this one here is pretty close though. H approaches 0. H. Yeah, this is going to be e plus h. This one here is x plus h. So that's the suspect thing here. And then we don't have e to the e up here. Yeah, so C is our correct answer. 4, calculator problem. Let f be a function given by f of x equals 3e to the power of 2x, and let g be a function given by g of x equals 6x cubed. At what values, or values of x, do the graphs of f and g have parallel tangent lines? Well, we're going to have parallel tangent lines where f prime of x is equal to g prime of x. So let's find what those are. So f prime of x is equal to 3e to the power of 2x times the derivative of this, which is 2. So we're going to get 6e to the power of 2x. And g prime of x is equal to 18x squared. And so basically we're looking for the x values where 6e to the power of 2x is equal to 18x squared. So if we can graph these in our calculator, and this is a calculator problem, we're going to put 6e, and there's e to the power of 2x, and we graph that, and we enter another equation, which is going to be 18, f of x equals 18x squared. And we see where where they cross. It looks like it's right here. Now, over here at the right, you'd be tempted to think that they could cross, but remember the exponential function is increasing faster than this black quadratic function, so these things are never going to touch up here. And so our intersection is going to be right here. And to find our intersection, we can go to Menu, Analyze Graph, G, and we're going to find intersection, Analyze Graph, intersection. It says lower bound, so I set a lower bound and come up here to a higher bound. And so we have this value here at, okay, we have, I'm going to put the hand over there, see if that works. I'm going to try to do the plus sign there to see if we can get, I think that's going to work out though. Okay, so if we press, is it shift? Yeah, shift. There we go. We'll go out by, so we can go negative 0.3906. So we get x equals negative 0.3906. 3906, let me put that here. And so you could say negative 0.391. That would be possible, but you're looking for the first three digits here. So that would be our answer for this one here. That's where f prime of x equals g prime of x. So good luck. Quite easy to do here. And thanks for viewing.